I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg Engineering College, Ghaziabad. The topic that I am going to discuss today is the use case diagram and introduction. And this topic is covered under the subject Software Engineering meant for MCA third semester students with the subject code KCA 302. So coming to what a use case diagram is, the use case diagram is basically, it represents the dynamic behavior of a system. Now, whenever we are going to develop a software, the development of a software moves into different phases. Like it starts with the planning phase where the requirement gathering takes place. The analysis and identifying the specifications of those requirements is done. Then the designing part is done. Once the design part of the software is done and is documented properly, then the coding, then comes a coding phase where the whatever designs have been developed, the coding is done on that basis. Once the coding is done, the software is deployed at the user's end, and then comes a maintenance phase. So when we are moving from the gathering of requirements to the maintenance phase, we have a phase that is the designing phase, which includes the designing of different designs or the documents in order to get, in order to be clear and in order to establish the functionalities between different components of a system that the user wants. So one of the design that we prepare is the use case diagram. It represents the dynamic behavior of a system and it encapsulates the system functionalities by incorporating the use cases, actors and their relationship. So if we talk about a use case diagram, if we talk about the use case diagrams, the use cases, the actors and their relationships are three major components whenever we are working on any of the use case diagram. So these are the models, the tasks, the services and the functions that are required by a system or a subsystem of an application. It also depicts the high level functionality of a system and it also tells how the user would handle a system. So these use case diagrams, whenever we are working on these use cases tells about the functionalities that a system would be performing, and these functionalities will be handled by what all people comes under the actors. And relationship talks about how would be the relationship. Will it be in the form of a direct relationship, or it could be an inherited relationship, or of any other type, or a generalized relationship. Those all relationships are discussed when we are talking about the relationship component of a use case model. So the purpose of the use case diagrams are, it gathers the system's need, as we have already discussed that once the requirement analysis is being done from the by the development team by collecting all the requirements from the user, then we start working on the use cases. So it will talk about all the needs that a system would need. Then it depicts the external view of the system, how the system would look like, how the people would be interacting with the system, how different use cases will be interacting with each other, or how different functionalities or modules will be interacting with each other. It recognizes the internal as well as the external factors that influence the systems. It represents the interaction between the different actors, as we have already discussed these. So now coming to different notations or the components of the use case diagram, as we have just talked about, is the first one is the use case. So this use case represents the high level functionalities and how the user will be handling the system. So this use case is depicted by an oval shape. This is a UML use case notation. It is an oval case. It is oval in shape, and then whatever use case you want to write will be written over here. Suppose whenever, suppose I am making a library management system wherein I want to have a use case of issuing the book. So the use case that I will be using would be in the oval shape, and I would be writing the issue book inside the oval over here. So it represents a distinct functionality of a system, a component, a package or a class. It could be anything. It is denoted by an oval shape with the name of the use case written inside the oval shape, as we have just discussed. Now, this issue book is a functionality of a system that we just talked about over here. So, every distinct functionality is written in a use case, and then its interaction with different people will be talked about. The next component or the next notation that we have is the actor. So, the actor is denoted by something like this, which talks about a human being. So, if we talk about the issue book, now this issue book will be taken up, can be done by the student. The student can ask for the issue book, or it can be handled by the admin also, because the admin or the librarian is responsible to issue the book to the student. So, we would be having two actors when we are interacting here. So, one would be the student and the other actor could be the librarian. So, this would be the librarian. So, all those people who will be interacting with these use cases are the actors. So, an actor is an entity that interacts with the system. A user is a best example of an actor. An actor is again an entity that initiates the use case from outside the scope of the use case. So, outside the scope of a use case means when we talk about this, we have a scope of a use case like this. Now, this actor is not involved into the use case, but it is accessing all these use cases by staying out of the whole of the system. One actor can be associated with multiple use cases in a system because an actor would be performing multiple functionalities. For example, if we look back into this use case diagram, where a student can issue a book, he could also return a book, he can submit the fine, he can check the catalog. So, looking into the catalog, returning the book, calculation of fine or paying the fine are all the use cases through which with which the student would be interacting. So, one use case could be return the book, one use case could be fine calculation. So, this student would be interacting with all of them. Similarly, we have the librarian who would be interacting with the book, the returning of the book, the fine calculation, etc. The major important part is the communication link. Now, this communication link is the link which connects the use cases with the actors. So, the participation of an actor in a use case is shown by connecting an actor to a use case by a solid link. So, we have this line which connects the actor with the use case. So, this is again an example of a library system wherein the student is connected to the use case borrow books through this line. So, actors may be connected to the use case by association, indicating that the actors and the use cases are communicating with each other. Now comes the boundary of a system. So, as we just talked about, like the boundary of a system is a boundary wherein all the use cases are collectively shown over here. So, this is a system. It talks about the whole of the system as a whole, and all the actors would be staying out of this system and would be interacting with this, the use case. Like if we are talking about the library management system, so this is library where the issue, the return, the fine, the catalog search, or could be the login. All these things are the use cases. And if we are talking about the student, can be issue the book, can get the book issued, return the book, he could pay the fine. Similarly, the librarian has a login, he has an access to the catalog, the fine calculation, the issue of the book, and so on. So, the system boundary is potentially the entire system as defined in the requirement document. For large and complex system, each module may be a system boundary because we have all the use cases may not be able to be accommodated into a single system. So, we can have it for different classes or different modules. For example, for an ERP system for an organization, each of the modules such as the personal information, the payroll, the accounting, etc. They can form the system boundaries for the use case specific to each of these business functions. The entire system can be a part of these modules. It depends upon the overall system boundary. So, how are we connecting these use cases with relationships? The use cases share different kind of relationships. It is a decision of the software analyst of the use case diagram, like which relationship they want to establish between any of the two use cases. The relationship between two use cases is basically modeling the dependency between the two of them. The reuse of an existing use case by using different type of relationship, it reduces the overall effort that is required in developing a system. So if we look into the extends relationship, it depicts with a directed arrow that is having a dotted line. So this is how we show the extend relationship, with the keyword extend written on the top of the dotted line with two conical arrows like this. The tip of the arrowhead points to the base use case and the child use case is connected at the base of the arrow. So if we look over here, we have the login account which has the extension point to the invalid password. So that means in case the user is logging in into the account and he or she enters an invalid password, so that invalid password would directly reconnect to the invalid password use case and the rest of the things will be taken care of by this use case. So this shows an extends relationship, which is an extension that is provided to the main or the base use case. So if we look over here, the student is requesting for the book. Now the extension to that request a book includes searching the book in the catalog. So this is an extension. If the student wants to request a book, he can only, the user or the student is only interacting with this use case. But this use case is again interacting with the search use case with the help of the extend relationship. The next relationship that we have is the include relationship. So when a use case is depicted as using the functionality of another use case, the relationship between the use cases is the include relationship between the two use cases. So if we look over here, we have the place order, which is using this login. That means this login is mandatory for this place order use case. That is why here we'll have the include relationship again depicted on a dotted line under the conical brackets. So the includes relationship from base use case to child use case indicates that an instance of the base use case will include the behavior as specified in the child use case. It is again depicted by an arrow having the dotted line and the tip of the arrowhead points to the child use case and the parent use case is connected at the base of the arrowhead. So if we look over here, the student is interacting with the borrow book. Now when the student is going to borrow a book or issue a book, what the admin needs to do is, this borrow book will include all the things that are related to checking the fine. The student will only be issued a book when the fine checking is being done. That means it includes this part is mandatory when this use case is to be done or is to be executed. Similarly, the book can only be issued when it is in the reserved books. If the book is not available in the library, then in that case, that book cannot be issued. Or if the student has a fine pending, then the student has to submit the fine and only then the book will be issued to the student. So these two are the mandatory parts that need to be checked. It includes all the functionalities of these two use cases whenever this use case is to be executed. So here, this is the base use case and these are the child use cases. The next type of relation that we have is the generalized relation. So the generalization relationship is a parent-child relationship where the child use case is the enhancement of the parent use case. For example, here we have the store patient records in a paper file. Now, how will this be done? This will only be done when we have the computerized files. For example, the another example, if we are searching any of the book, now that searching of the book can be done by the number that is written onto the book, or it could be searched by the author name. So that search is the generalized part which includes different categories. So that search is a generalization of searching by the author name, searching by the date, by the book name, or it could be by the call number, or it could be by the barcode. So these all are different types through which the searching of the book can be done. Now, this generalization relationship is depicted with a hard line with a triangular over here. Now, how to draw a use case diagram? The first thing is to analyze the entire system carefully to find out every single function that is provided by the system. These functionalities are converted into various use cases which will be used in the use case diagram. The second thing that we have is to enlist the various actors or things that are going to interact with the system. So these actors are responsible for invoking the functionality of a system. Actors can be a person or a thing. It can also be a private entity of a system. These actors must be relevant to the functionality or a system that they are interacting with. They explore the relationship of a particular actor with the use case or a system. The total number of ways an actor could interact with the system to be identified. A single actor can interact with multiple use cases at the same time, or it can interact with numerous use cases simultaneously. Now, there are certain tips while we are drawing a use case diagram. It should be as simple as possible so that everyone can understand that use case. It should be complete. All the relationships and all the use cases should be mentioned into the system. It should represent all the interactions with the use cases. The name of an actor or a use case must be meaningful and relevant to the system. If there are too many use cases or the actors, then only the essential use cases should be represented. Annotations must be used wherever they are required. It should describe at least a single model of a system. If the use case diagram is large, then it should be generalized. So here we have an example of the student management system, wherein we have a student and the teacher as the two actors, and we are dealing with how these student and the teachers are interacting with the use case. So this whole part is the system wherein we have all the use cases uploaded, all the use cases mentioned over here. So the first use case is the check attendance, which the teacher and the student both can do. So it is related to the student as well as the teacher. Again, the check timetable part can be done by the student and the teacher. So both are checking those. Test scores can also be checked by the student and the teacher. Now, when this attendance is to be checked, in that case, the teacher has to update the attendance. So here the student is not interacting with this use case. Instead, the teacher is only interacting with update the attendance and update the marks of the student. So when this update score is done, only then the student is able to check the test score. So here we can have an include relation between these two use cases. So here we have two of the actors, a student and a teacher, and here we have a total of 5 use cases that represent the specific functionality of a student management system. Each of the actor is interacting with a particular use case, and the student actor can check the attendance, the timetable, as well as the test marks on the application or a system. This actor can perform only these interactions with the system even though other use cases remain in the system. It is not necessary that each actor should interact with the use cases, but it can happen. The second actor, named as a teacher, can interact with all the functionalities or the use case of the system. This actor can also update the attendance of a student and marks of the student. So these interactions of both the student and the teacher actor together sums up the entire student management application. Similarly, we have an online shopping website example wherein we have the web customer and the generalized relationship of the registered and the new customer is shown over here. Now, whenever the customer would be viewing the item or he would be making a purchase, in that making a purchase would include viewing the items from the cart. Similarly, we have service authentication, the identity provider, the credit payment services, the PayPal. These all are the different actors who are acting or who are interacting with the online shopping website. So, these are the functionalities where the top level users could view the items, make the purchase, check out or client register. We have the view items, which is further extended by the use cases such as search item, browse items, view recommended items, add to shopping cart, add to wish list, etc. So if we look into the view item and the customer notification, we again have all these use cases which are either into the extend relationship or the include relationship. So we have again a more detailed use case diagram where again these all are in the extend or the include relationship, wherein these four actors are interacting with the use cases or the system. So the uses of the use case diagram, it is useful in analyzing the requirements of a system. High level visual software designing is there, capturing the functionalities of the system, forwarding and reverse engineering of the system using various test cases. So if we look as a whole, the use case diagrams are a way to capture the system's functionalities and the requirements in the UML diagram. They capture the dynamic behavior of a live system. It consists of a use case and an actor. It represents the distinct functionalities of a system, component, package or a class. We have the actor as an entity which initiates the use case from outside the scope of a use case. The actor must be meaningful and relevant to the system. And the overall purpose of the use case diagram is to capture the core functionalities of the system. That's all for today.